So this video is going to focus on the properties of exponents. This is how we're going to start things off. So what I would like you to do is pause the video, try to solve all of these. All right, so now that you've had a chance to kind of go through and take a look at them, here are all the various answers. And it says here that it wants to contain only positive exponents is what it says. So let me go back here. So only positive exponents. So like this is 4m to the fifth, which makes sense. Ones where it gets a little tricky is one like here. Now notice that it's 12 over AB, and the reason why is because I have my 4 times my 3, which is 12, but this a to the third and a to the negative fourth, that becomes a to the negative first. Well, since I can't have any negative exponents, it will be 1 over a, if that's the case, if it's a to the negative 1. And then b is going to be b squared minus b cubed, which will be 1 over b. So that's why this answer is 12 over ab. Another tricky one for some people is one right here, number 13. If I look at this, I'm going to take 4 times 4 times 4 times 4. I get 256. I'm going to take 0 to the fourth power, which is still 0, and r to the 0 power is just 1. So this will be 256 times 1, which is why the r disappears. If there's any questions, please feel free to contact me outside of class or email me. Let's actually go to the lesson though. So here we go. So I want you to go through and try to write these in standard form. So pause the video again. And here is the answers, or here are the answers. The whole idea for the day is to write a number in scientific notation. So we're going to use things like this, like lime juice, for instance, right? And we want to figure out what it is in scientific notation. And I have to put it between the 1 and a 0, and then it's going back 2 spots. So this would be 1 times 10 to the negative second. I can look at this chart and figure out 1 times 10 to the negative second and realize that this right here, lime juice, is an acid. For eggs, I'm going to go over here and I have to move it over 1, 2, 3, 4, 5, 6, 7, 8. So this will be 1 times 10 to the negative 8, which is going to be a base. Distilled water is going to be 1 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. So this one's completely neutral for distilled water. We can continue this with ammonia water and so on. And as you start to figure these things out, it works really well with this chart. And you can figure out if they are acids or bases. In terms of scientific notation for large numbers, if I look at this right here, this would be like 1. Let's just make this a little bit smaller here. So I could take like 1.8. Write this down. So 1.8 times 10. And if I go here, I'm right here now. I have to go back 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 10 to the 9th. And when I do that, what I'm basically doing is I'm going to write this out. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. I plug these in with placeholders or zeros. And if I go through here, I'll have my 1,800,000,000 miles, which is pretty far. And that's what I'm doing for all these. You'll have like 1.8 times 10 to the 9th. And you can keep on doing these. You can see what, how much smaller these actually are. So then we're going to take this and write these numbers in scientific notation. So pause the video and try to figure them out. Here are the answers. So you can tell right away when you look at this, this is the largest number, of course, because it's 10 to the 10th. The smallest one will be this one here because it's 10 to the negative 10th. All right, so this key idea is basically what we talked about before. If it's greater than 10, it's moving to the right. If it's between 0 and 1, it's moving to the left. These are getting very small, and these are getting bigger as we look at them. You kind of see how this works here. So Google purchased YouTube, this is a while ago, for $1,650,000,000. Right in scientific notation. Got to move this place back. So you have your 1.65, so it's between the two numbers. And then it's times 10 to the 9th, because there's 9 of these places that I'm going to have to move to get back to this again. So that's why it's 1.65 times 10 to the 9th. Here's the second one. Try to figure this out. I know that it's going to be 2.68 times 10 to the 1, 2, 3, 4, 5, 6. So 10 to the negative 6th. I want you to try doing a couple of these now. So write these numbers in scientific notation. Perfect. Here you go. Check them out. This one here says that we have this many albums. How many more copies does it need to sell to receive the award, which is right here. So we're going to actually go through, we're going to subtract these numbers. So let's go and try to do this. So this will be 1 times 10 to the, if I look here, I have 7, right? So 1 times 10 to the 7th. And this number up here is 8.78 times 10 to the 6th. We'll have to make these the same so I can actually subtract them. So I'm going to change this and put down 10 times 10 to the 6th. And now I could line up my 8.78 times 10 to the 6th. Oops, 10 to the 6th. And when I do this, if I take 10 minus 8.78, I'm going to get 1.22 times 10 to the 6th power. And that's my actual answer here. It is right here, letter C. Here's another example where you would put these in order from least to greatest. And if I look here, right away I can figure out that the furthest ago, so the most distant time, I'm looking for the largest number here, would be this one here, Paleozoic, because that's how many years ago it was. So it's a lot. Then I'm going to go over to this one, and then to this one. So again, it's Paleozoic, because that's the furthest away, then the Mesozoic, and then the Cenozoic right here. So now we're going to do a little bit more practice here. And first what we're going to do is look at these. I want you to pause the video and try to figure out what you'd have to do to add these together. All right, hopefully you realize that you have to kind of change these things. So I have this, I'm going to change this one into 7th as well, 10 to the negative 7th. So I have to move this over 2 spots. So that's why it's 0.0948. And now I can add these together, and you line these up. We're in the decimal point, and this is the actual answer here. So that's the first one. The second one, I want you to pause the video, try to solve this one. Notice it's subtraction here. So first of all, I leave it as it is. I then want to move this back. And to move this back so it's negative 3, because right now it's negative 7, I now have to go to the right. But I have to go over 4 places, right? So my answer will be because right now if I go back 7, I'm over, I have to go back quite a few. So if I go to the left 4, that means I'm going to have 3 zeros and then 0.3 or 3.2. So it's 1, 2, 3 zeros and then 3, 2. I'm going to line these up right in the decimal point, and when I subtract them, I'm going to get 1.49967 times 10 to the 3rd. Here's one last one I want to do. So notice that this is 10 to the 8th, 10 to the 5th. If this is 10 to the 8th, this is going over 8 places. I have to make it so it's only 10 to the 5th, right? So I have to move this to the left 3 places. Or I'm sorry, to the right 3 places. So 1, 2, and then 3. So I have the 0 here. That's why I have to go over that. And now I have 10 to the 5th as well. I can line this other one up. And then when I'm adding these together, I should get this number. And since this is not in scientific notation, I have to take this back to 5.6267. If I move this back 1, 2, 3 places, that's now 10 to the 8th. So I had to turn it back into scientific notation.